All right, in this video, we are going to talk about how to construct confidence intervals with when sigma is unknown. We are going to review very quickly about what we did in section 8.2 because we're going to see that it's very, very similar. Okay, so if you go back in this part, we actually derived these formulas, are not really derive them, but just show basically the connection between this this variable z and the form of the confidence intervals. So in back in section 8.2, right, then we were using z, right, because in that section we had the value of the population standard deviation. Okay, so this was the format of the value that we were using. And then basically what we did was to get the lower limit and upper limit, right, we could do a little algebra on this formula and get these forms here. This for the lower limit, right, and basically it was solving for mu, right, in this equation. You'll get a formula that looks like this. And then the question was the value of z of alpha over 2. That was based on the confidence level, right, that we were given for the problem. So the alpha over 2, we got that by subtracting the confidence level from 1 and then dividing that result by 2. And that will give us this value here. All right, so these formulas right here came from this formula. And then the margin of error, right, was this part here that we were adding and subtracting to the sample mean. Okay. All right. And so that was the situation in 8.2. And you're going to see we're going to do almost exactly the same thing. I'm not going to go through it step by step, but just so you can relate this new material in section 8.3 to what we were doing before. And so in this case, right, we were using S, the sample standard deviation. All right, and then if you do that same procedure that we talked about way back in section 8.1 with this, you'll wind up with these values. And you can see this is almost exactly the same format as before, just slightly different, right? Here we're using S, right, the sample standard deviation. And here, instead of it being z of alpha over 2, it is t of alpha over 2, right? Because we already talked about in a previous video that if you're using the sample standard deviation, then this is not normally distributed like it is for z, okay? So you have to use the t distribution. All right, but other than that, everything just kind of falls through pretty much the same. So that same explanation that I gave back in section 8.1, if you followed it, right, then it's not a real stretch to see that this is true. Okay. Okay, so that brings us to the actual procedure that we are going to use for constructing a confidence interval, right, for a t distribution, right, using the t distribution. And so we're going to find a confidence interval for a population mean mu, right? The assumptions are we need a simple random sample from a normal population or a large sample, right? And here the key to differentiating between these when you read these problems is sigma is unknown, right? So if you know sigma, then you're going to use the one mean z interval procedure. If you do not know what sigma is based on the problem that they give you, you're going to use the t interval procedure. Okay. Okay, so the steps you would go through, right? Number 1 is to find the value of t of alpha over 2. Okay, so again, to find what alpha over 2 is, we are going to subtract 1 from the confidence level to get alpha and then divide it by 2. That will tell you what t of alpha over 2 is. Then you'll need to find the degrees of freedom, which is easy, right? It's just the sample size minus 1. And you will go to table 4 and look up the value of t of alpha over 2. Okay. And then this will be the form, very similar to what we did in section 8.2. This is the sample mean. This is the value of t of alpha over 2 that you just found. S is the sample standard deviation, and N is the sample size. And so that will give you your confidence interval. Okay, and the margin of error, if they ask for that, is this T of alpha over 2 times S divided by the square root of N. So very, very similar to the procedure for the Z interval, other than, you know, you're using this different distribution here. Okay. All right. So there's the formula for the margin of error. And now we are going to do a couple of examples. I'm going to separate those out into 2 videos, one for each example.